Hello guys, let me explain linear probabilistic modeling to you guys. First of all, linear probabilistic modeling, just like the word says, is based on a linear graph, right? A linear graph that has x and y, normally known as x is equal to mx plus c. When you have nx plus c, in this case, we're going to see it as y is equal to beta naught plus beta 1x plus epsilon. Epsilon standing as the error from the point to the actual y position, b naught being the standard number that we're actually going to base our information on, and b1 being the variables. Variables that can only increase either by one numbers. So there could be more than one betas. There could be beta 1, 2, 3, 4 consecutively until you get a lot of them. We're only going to be working with 2 this time. Let me go ahead and work with my example. We can see the numbers are increasing linearly. If the numbers are increasing linearly, that means that every year we're increasing about the same amount of users. I'm going to be showing the probability of people using a web page in 2010. We're going to compare it to the amount of uses, right? The amount of uses is going to be the b, right? So we're going to have b naught to be our basis number, right? Which is normally at 3, that's where it starts. Then you have that for every one need, it's gonna increase. 6 people, 3 needs 9 people, 4 needs 13 people. That means it increased a little bit more, and that's where epsilon comes in. Epsilon means the error. That's why you can see that some points are straight on the line. For example, that point's on the line, that point's on the line, but there's some points that are above the line. Those are plus epsilon. And the points that are under the line are minus epsilon. That means that there's a mistake from the actual y that actually comes into the place, right? I also want to compare this to what it is today. So we come over here, and I'm now showing you how the probability of a person using the web page in 2017. If you have 4 people, one person that needs 4 needs is going to start coming into the web page around 12. Now, 4 would be B1, right? And then B naught would be 1, which is the minimum amount of times a person who owns the web page with no needs will actually have to enter the web page, right? You have to base your y on your x, right? All the values are the probability that y when something happens to x. Thank you for your attention, and I enjoyed your class.